everyone, welcome back to 10 Minute IO, an online library of bite-sized information for all topics related to industrial organizational psychology. My name is Stephen Jong. I'm an IO psychologist or IO practitioner. Today we'll be talking about part two of correlations. Just do a quick review. We defined correlation. Correlation is what tells you the degree to which two or more variables are related. We talked about the range of correlation being going from -1, which is a perfect negative correlation, to +1, a perfect positive correlation. Zero correlation is when there is no relationship, or near zero correlation, being when there's no relationship between two or more variables. The question is, how do you calculate a correlation? We'll be using Microsoft Excel today to answer that question. Is smoking related to or correlated with coffee consumption? First step is to have the data in the data file, Excel spreadsheet. You have in column A the participant or the subject, Joe, Deepti, Susan, and so on. And in column B, you have the number of cigarettes smoked per day. And in column C, we have cups of coffee drank per day. It's important to remember that for each subject or participant, you have all of the variable data for the variables of interest in the same data file. Otherwise, there's no way to calculate a correlation. Once you've done that, then you choose any blank cell in that spreadsheet. I chose the one on the bottom right-hand corner there, and type in CORREL, and Excel will prompt a correlation formula. You double-click on that, and I'll show you how that's done in a few minutes. And simply highlight the first variable and the second variable separated by a comma. You can see that first variable goes from B2, cell B2 to B12. Second variable, or did I say the first variable goes from B2 to B12, and second variable goes from C2 to C12. Once you do that, simply enter, and the program will produce a correlation or decimal, in this case 0.15. That means there's a positive correlation between number of cigarettes smoked per day and the likelihood of drinking coffee. That's not a huge or a strong correlation, but it's a moderate, statistically significant correlation. Second question is weight related to or correlated with a person's height? The question is, or taller people, do taller people tend to be heavier than shorter people? And again, here I'm using the same group of people, Joe, Deepti, and so on, in column A, and you'll see that I changed the variables to weight and height in columns B and C. Same steps. Enter the data, choose any blank cell, and type in CORREL, short for correlation, and enter. Or after you highlight the first variable, comma, second variable, enter. And here you'll see that the correlation is 0.89, which is a very strong positive correlation. This indicates that taller people tend to be heavier than shorter people. Let's move on to question number 3. Is employee engagement related to productivity? Same deal, same group of people. Now, in typical databases, you'll have hundreds, if not thousands, of people. Here, I just have 11 people, just as an illustration. In column B, you'll see engagement level for each individual or subject or participant, in this case. Engagement level 10 being extremely engaged, 1 being extremely disengaged. And in column C, you'll see that the average number of widgets made per day, and this could be an average over 1 month, average over 1 year, whatever you have data for. Number of widgets here is being used as a proxy for productivity. So once you have the data, then choose any blank cell and enter the formula again. Again, depending on how many cases or participants you have, that number coming after the letter there, B2, B12, will change. It will start with B2 and it could go up to B2000 if you have 2,000 people in your database. Once you do that, press enter, and here we get a correlation of 0.6, which is fairly strong positive correlation. I will show you how this is done using Camtasia next.
Now, we talked about the correlation between cigarettes smoked per day and the amount of caffeine consumed through coffee. Now, here you'll see, this is Microsoft Excel. You'll see in the first column here, column A, participants. You have Joe, Deepti, Susan, and so on. We have a total of 11 participants, and we have the number of cigarettes smoked for each of these individuals. And along with that, we have the number of cups of coffee drank per day. Keep in mind that when you're doing correlation, you have to have both variables for a given subject or participant. Otherwise, you won't be able to estimate the correlation. So in this case, what you do is, I already calculated the correlation here, but what you do is you, just like I mentioned earlier, equal CORR, and you'll see this little prompt here, Corel. Double click on that, and what you're going to do is highlight one of the two variables. I'm going to highlight the first variable, number of cigarettes, and then you have to separate that by a comma, and then highlight the second variable, and then use a close bracket, and then click enter, and that will give you 0.15 as the correlation. Moving on to weight. Now I'm using the same participants here in column A, but instead of smoking and coffee, I have weight and height. Weight in pounds and height in inches. I'm going to do the same thing, equal Corel, double click, highlight the first column, first variable, separate by a comma, highlight the second column, close the bracket, and then you get 0.89 rounded up. Moving on to engagement and productivity, again, I'm using the same group of people. Engagement level is some sort of an average engagement level that's collected through employee engagement surveys. For each individual, you can calculate this. You're going to do the same thing, Corel, double click, highlight the first column, first variable, separate by a comma, and then this is the average number of widgets made per day. This could be averaged over a month, averaged over a year, whatever data you have. And then you close that bracket and then click enter, and you see that the correlation is 0.60 rounded up.
Now you see how to calculate correlation using Microsoft Excel. The question is, so what? What is correlation useful for? Where's the value? Well, correlations, when used in, if you've heard of multiple regression, which is just an extension of correlation, correlational analysis, you can use that to make forecasts or make predictions, because if you know that two or more variables are related, and you know the magnitude of that relationship and the direction of that relationship, meaning positive or negative, then you can use that information to make predictions, assuming that you have data on both. For example, outside temperature. If you know what the outside temperature is, you may be able to estimate how much ice cream you will sell if you're an ice cream salesperson or you have an ice cream business. The outside temperature will help you predict the amount of ice cream cones you'll sell for that particular day. If you're a marketer, then you can use correlations or regression to figure out how much to set aside, how much of a budget to set aside for marketing expense. If you know that there's a sweet spot, if you spend a certain amount of dollars, it leads to a certain amount of sales. You can optimize the dollar spent for your marketing. Last example here I show is employee engagement. If you know that there's a positive relationship and you know the strength of that relationship between employee engagement and customer satisfaction, you can estimate, if you were to improve engagement by a certain amount, how much customer satisfaction will increase. So it can be very useful, especially when it's used in multiple regression where you have multiple variables combined into a single analysis. Thank you for watching. Please subscribe if you like the video and share the link with others. Coming up next, we'll be talking about levels of measurement. Thank you again.